Elimination method. Hint, you're going to eliminate. So if we look at these two equations, if we added straight down, do you see how these are going to eliminate?
Yeah.
Leaving you 2x equals, and negative 6 and 14 gives you 8. It's a really cool method because it's really quick and easy. Now, to finish this off, we have to divide by 2, and we get x equals 4. You got a pretty quick, easy answer. Now, we're only halfway there, and people sometimes stop there. Don't stop. We need to take this 4 and plug it into the first or second equation. It doesn't really matter which one. I'm going to choose the second equation. And instead of x, I'm going to put a blank, because x is 4. X is 4, so I plugged it in to the second equation. So now I solve this, and I'll get y. So I have 2y plus 20 equals 14. To get y by itself, I have to minus this 20 over. So I have 2y equals negative 6. And lastly, to get y by itself, you divide by the 2. So you have y equals negative 3. The coordinate where these two lines cross would be 4, negative 3. Remember, it goes x, y. You're looking for a coordinate where the two lines cross. It's a really cool method, especially when things are set up nice and easy. Too bad, number 4 is not set up nice and easy. First of all, are the x's and y's lined up?
No.
No. For 4, we first have to rearrange it so the x's and y's line up. So I'm going to rearrange the top so it matches the bottom. So I'm going to take this 4y right there and plug it right there. And the 2x, put it right there. And the 10. All I did is rearrange the first equation. Now, that still doesn't help me. Because if I add straight down, will it cancel?
No.
No. So what you do is you look at it and go, okay, if I multiply these two equations by something, can I make either the x's or the y's eliminate?
Yeah.
And what I see is a 3 and a 2 is easier to deal with than a 5 and a 4. So I'm going to take this 2 right here and multiply the top by 2. And this 3 right here, I'm going to multiply the bottom by 3, but I need it to be a negative 3. You'll see why in a second. So, if I multiply 2 times 5y, I get 10y. 2 times 3x, I get 6x. And 2 times 11, I get 22. If I multiply negative 3 times 4, I get negative 12y. Negative 3 times 2x, I get negative 6x. And negative 3 times 10, I get negative 30. These are now my two equations. Again, I rewrote the first one, and then I multiplied the opposites of these. Now, could I have done 5 on the bottom and 4 on top, and one of them negative? Yeah. But I chose what I thought would be easier. Okay. If I add straight down, that's gone. If I add straight down, I got negative 2y. Add straight down, I got negative 8. So I got to get y by itself, so I'm going to divide by negative 2. And I now have y equals 4. So I got half my answer. I go back up to preferably probably the first two equations and think which of these two would be easiest to plug 4 into. I think the top one's a little bit smaller numbers. So I'm going to take the first equation, 2x plus 4y, but instead of y, we're going to plug something in. And what's going to go in there for the y?
4.
4. So we now have, it looks like 2x plus 16 equals 10. And get x by itself, we're going to minus the 16 over. And it looks like the last step would be to divide by 2. So it looks like we have x equals negative 3. So that's not my final answer. My final answer is a coordinate. Which one's first? Negative 3 is x and 4 is y. That's the coordinate where these two cross. These take a little bit more work when you have to multiply. This one is really slick and easy. Number 5. It's not very pretty, but we can rearrange it. So look at the top one. Let's rearrange it with the bottom one. So what's going to go underneath the 6y? Looks like a negative 3y. What's going to go into the 4x or negative 4x? The positive 2x. And do you see this minus 2? Do you see how it's going to move over to be on the other side of the equal sign to match the negative 4? So if we move it over, it becomes a positive 4. So again, I rearranged the top one to match the bottom one. Now, can we cancel? No. But do we have to multiply both of these?
No.
What you can notice here, what if I just multiply the bottom? Could I just multiply the bottom by 2? Sometimes you can multiply just 1 and it does everything for you. Watch. If I multiply the whole bottom by 2, watch what happens. I get negative 6y plus 4x, 2 times 2, plus 4.
Don't you get positive 6y?
Now, when you multiply by positive 2, now, let's rewrite this equation right here. Is that okay? So we have it right underneath it. Okay. Okay, we rewrote this one right here. And this blue one came from multiplying the top one by 2. What happens? This and this cancel, leaving you nothing over here. Doesn't this cancel too? Everything disappeared. Which is actually easier. Because we're done. This is a true statement. So it's either going to be infinite solutions or no solutions. And a true statement is infinite solutions. Meaning these two lines would be right on top of each other. Now if everything dropped out but we had a false statement, that would be no solutions. So looking back, sometimes you only have to multiply one of them. Sometimes you have to multiply both of them. Sometimes you don't have to multiply anything, just cancel, done. Elimination, hint the name. You're going to eliminate something.